Hi, pal. How you doing? This is Tony Lockwood. We're in Cleveland, Ohio, right across from where the Browns play. And we're at CAASE 18. 18 means 2018 for those of you who need a touch tone. And that is a conference on advancing analysis and simulation in engineering. It's co-hosted by Digital Engineering and by the Nathans Group. I got a special guest here for you today. We're going to talk for about 10 minutes about simulation type stuff, believe it or not. Please introduce yourself, who you work for, your title, and what's on your mind, what's happening.
And all that stuff. Yeah, thanks, Tony. My name's Richard Mitchell. I work for ANSYS, based out of the Pittsburgh office, which is the ANSYS headquarters.
Yeah.
Been with the company for a little over 12 years now. Started off as an application engineer in the UK, and now my role is looking after product marketing and product management of the structural line of products, which has grown quite a bit over the years.
You're right, yeah.
As you probably know, ANSYS is involved in lots of different areas right now. Structural mechanics, fluid dynamics, electromagnetics, still very much part and parcel of the core of the business, but getting involved with lots of other things. So,
So what's the news in your slice of ANSYS? How's that? There's a lot.
There is.
There's so much going on with ANSYS right now.
There is. I think that the whole simulation market is and the audience for simulation is really starting to turn a corner, and where a lot of our customers and a lot of use cases were around looking at individual problems, like my first analysis problem, I'm sure many of other people's was a hole in a plate, so a very simple structural analysis looking at something in a very controlled, isolated circumstance. And now engineers are being pushed more to look at things wider than that and take into account other effects.
And multiple physics.
Multiple physics, yeah. It started off a few years ago as kind of a niche application with, you had to have a really strong need. You really needed a really detailed technical competence to kind of tackle these problems and a fairly sizable compute resource. But companies now are looking to say, okay, I want to take my structural analysis and add a bit more to it. But I guess something from my point of view, or my perspective, which is, say, my slice of ANSYS, which has kind of changed things a little bit, is kind of moving from looking at taking a model from a CAD system that's been designed and predicting how it's going to perform, and then it goes off to manufacturing. We're now moving towards, as an organisation, looking at things like digital twin. So you start.
For some of you may not be familiar with digital twin. Could you just give us a little.
So let's take an example maybe of an aircraft landing structure. So you'd start off with a CAD assembly of this design, and then you would go and do some simulation to check it would meet the requirements. So you'd say, okay, this needs to land with these loads on it, needs to be stowed, deployed, carry these forces, etc. Now with a digital twin, you basically take your simulation model and you keep a digital version of each one of your landing gear that's been made, and with that you might have things associated with it, such as it was manufactured at this plant with this batch of material by this operator and this machinery, and then during its life you would say, okay, it crossed the Atlantic this many times and these were as predicted. They kind of fall within normal limits, but we know that on this occasion it had a particularly hard landing, or it was maintained on this date. We start to combine the design, the simulation, the manufacturing and the use information to create a digital twin of exactly what's gone on.
Right.
And what people and organisations are interested in doing is saying, okay, rather than having to maintain and inspect everything every month or every week or every how often it is, can I start to predict what's going to happen to that? And if something does happen during an inspection and I find something, what does that mean for all my other digital twins? What does it mean for my maintenance schedule? What does it mean for my design, my manufacturing? Do I need to chase everything down and figure out where all these problems are? So we're moving from this paradigm of kind of design, simulate, and forget about it towards design, simulate, and now we're taking real world information as that thing's gone on and figuring out, okay, we've got a small crack. Let's insert that in this digital twin and say, okay, is it a problem or is it just a surface finish issue?
Right.
And the whole kind of scope is blowing up, and It's pretty crazy.
It's fascinating stuff, actually. Yeah, because you're throwing it all in there. Data acquisition, predictive analytics. You got it all in there.
And I mean, ANSYS is an organisation. We play a role in a number of these areas, but from my perspective anyway, I think for digital twin to kind of really be adopted, you need to be plugged into all of these different things. Like, maintenance teams need to kind of be feeding information in.
Right.
As you say, like data acquisition from sensors and things, all of that needs to come together in order to fulfill this. And it's a big challenge, but if you could kind of say, okay, we had one instance, do we need to ground an entire fleet? Or is it fine?
Yeah.
Or can we just tweak something on the manufacturing and everything is okay going forward? Or what does it mean?
Yep.
So.
That's excellent. Now you must be hearing then a lot from the field about the challenges that your users are facing, and they turn to you for some of the tools to help them deal with that. My guess is digital twins is coming their way, and some are involved in it. But what are you hearing from the field of engineers? What do they want?
So digital twins is part of it, and a lot of people are trying to figure out what it means and how, does it fit their industry? Is it going to impact them, or is it just kind of another thing that's maybe for only aircraft manufacturers? Does it apply to people making cranes or other pieces of products? So they're coming and saying, okay, these are the things. How can we get ready for this? How can we prepare? What can we offer right now? But maybe, and this kind of falls in the same remit as well, or not maybe the same remit, but certainly within my slice of ANSYS is this change from design, simulate, and kind of off it goes kind of thing to say how manufacturing methods are changing as well. So additive manufacturing is something that's just it's come back when I was through college. We had the opportunity to 3D print a plastic part that we designed to see how it felt in your hand.
Right.
And you might find companies saying, okay, we're going to paint it blue to match the finished prototype and give it to a customer. How does it
look in blue, right?
And now we're saying, okay, I want to be able to design something on my CAD system and essentially press a button and get a physical component out.
Yeah, like you get this piece of paper. Right.
Yeah, exactly. And for some things, that's fine. If you're looking for a piece of plastic to direct a little bit of air onto a heat sink in a computer, it's not really carrying any load as long as it doesn't waft around or rattle too much. That's kind of the end of it. But when you start saying this is going to hold an aircraft engine on,
right,
you need to know a little bit more about it. And
and that gets you into the whole materials business.
The materials piece, and it no longer stops at this is my design, this is what happens when I put a load on it. This is my design, this is what happens when I put a load on it. Now if I print it this way, what do I get? Now if I print it this way, what do I get? If I make it out of that, if I use this machine or that machine.
Right.
So now the manufacturing and the design, the two influence each other.
Right.
So you need
they always have, but now they're really in there.
Yeah, I mean, when I went through college and I'm looking at, we're doing these projects and saying, okay, you need to design a housing. You can't drill a hole in something this big and then behind it drill a hole something bigger, because drill bits don't get bigger when they go in a hole. And if you're just doing a drilling operation, you need to think about the manufacturing process. It's the same for additive.
Yeah.
You can't just say, okay, I've got this random shape here, press print, it's going to work. No, you need to think about how is the structure going to be supported, what's the thinnest section you can have, and what does that mean. And
what's going on?
I've learned a heck of a lot about this in the last couple of years,
more
more
than you ever imagined, right?
And every time I talk to somebody about it, and a machine manufacturer or a researcher working on this, and they're saying, we're trying to figure out this, and it's like, that's yet another set of variables I didn't even know existed.
Right.
So,
you can do things inside the part that you can't really machine.
All of your limits that were there before are blown away.
Right.
But it's the promise that it offers is just so exciting. But the challenges in the way are people are starting to get the feeling for, and simulation is there to help, but we're working extensively with a lot of research places, a lot of machine manufacturers to figure out, okay, we know how to write software, how do we make it fit
what the machines do? Well, ANSYS just came out with the additive manufacturing.
We've got.
Sorry, I dropped the product name.
So we've got two products, and they're based on within the structural product family.
Right.
There's Additive Suite, which is kind of an end-to-end everything.
Yes.
We also have a standalone product called Additive Print, and that's kind of like take the geometry, go through a fairly simple interface, and it will have some different modes and predict some distortion. It will do distortion compensation, which is kind of nice as well. So we've got a full range of tools, and we're developing those out. It's going to build up to give material microstructure prediction, support generation. Some of this is there already, but this is kind of growing and growing and growing. And like our customers, we're trying to figure out, okay, what's really important to them, what makes a difference, and what's a nice to have, and give them the tools they need as fast as they can.
Right, and considering you're really in new territory, everybody's trying to figure it out. Yeah,
and I've had a few conversations with people at this event here about additive, and everybody's remarked, this is the demand for it and the interest in it is just crazy, but everybody's hoping that we have, or that there is the amount of knowledge about additive manufacturing that we have about, say, welding or forging.
Right.
So we have there's an organisation, the Welding Institute.
Right.
They've been around a long time. They spend a lot of time studying, okay, how do we join two pieces of metal? And with this welding method or that welding method, what's the heat affected zone? And, how does this impact the strength of my overall part?
Right.
Additive manufacturing is welding times 1,000,000.
Right.
So it's a big challenge, but an exciting one. So so that's taking a lot of my attention right now, and it's pretty interesting, pretty cool.
Yeah, that's exciting stuff.
Yeah.
I want to thank you for stopping by. This is we could probably sit here all day and talk about this. ANSYS, Richard Mitchell, is here, the ANSYS.com website. They got all sorts of things, case studies, on-demand webinars, anything you want. If somehow that web address doesn't stick in your head, drop the DE editors a line, we'll send it to you. And thank you so much for your time.
Great to talk
Thanks,
to you.
pal.